Logarithmic function, differentiation. Here we discuss how to take the derivative of the natural log function. The natural log ideally is defined in a very strange way by the integral. So the natural log of x is equal to the integral of 1 over t dt as t is evaluated from 1 to x being any positive number. We'll take a more closer look at that and relate the two, the integration of 1 over t with the natural log of x when we deal with integration of log functions. And then later on we'll talk about the inverse functions and tie that into the natural log and also 1 over x or 1 over t. The graph here of the natural log of x, you can see here that the domain is positive. The domain goes from 0 to positive infinity. The range goes from negative infinity to positive infinity. This function is continuous on the interval. Here on the open interval from 0 to positive infinity. A statement here that that the natural log is 1 to 1, meaning that there exists what we call a so-called bijective function. That is that for each x sub 1, x sub 2 in the domain of f that are different, distinct, then the function values f of x sub 1 is not the same as f of x sub 2. And so that gives us a 1 to 1, that each value, if we can find a value in the domain, it matches to one unique value over in the range. A very strong case, and we use that case in analysis where a function is said to be 1 to 1 to get at a very neat property which is called the inverse property. We'll talk about that when we get to that section. Logarithmic properties, straightforward, comes from algebra. The natural log of 1 is 0. The natural log of a times b. Here the product, the natural log of the product is equal to the natural log of the sums, or the sums of the natural log, excuse me. Number 3, the natural log of a raised to a power is equal to that power as the multiplier times the natural log. The natural log of the quotient is equal to the difference of the natural logs. So straightforward again from algebra. The base e number, fixed constant, is equivalent for close to 2.718, 28, 18, and 28, and so on. So if we have to deal with it, we can understand that the integral of 1 over t dt, as t is evaluated from 1 to e, is equal to 1, but this gives you the natural log of e, and we know that the natural log of e is defined as 1. Let's deal with how to find the derivative of the natural log. So the derivative of the natural log function, again, very straightforward. Let u be a differentiable function of x. Then the derivative with respect to x of the natural log of x is equal to 1 over x being positive. Now, if u is a function of x, then the derivative with respect to x of the natural log of u is 1 over u times du over dx. In other words, 1 over u times u prime. So straightforward. In a few seconds, we'll look at some of these and work some of the problems out. If it's the derivative involving the absolute value, you really compute this the same way you would number 2 up here. Here, u is positive, so we're getting the same argument. Similarly, that the derivative with respect to x, the natural log of the absolute value of u, is the same thing, u prime divided by u. Let's look now at some problems. We start with the algebra as a review, and then we look at some derivatives. I won't take much of your time. So we want to expand this out. So this is the natural log of x plus the natural log of y minus the natural log of z. Do you remember that? We expand this out. This is the natural log of x minus 1 divided by x to the 1/2 power. So the power then becomes the multiplier of the natural log. So after that, we break down the quotient into the difference of the natural logs. So here we have 1/2 times the natural log of x minus 1. Don't throw away the 1/2. It's still now minus 1/2 times the natural log of x. What if you go the other way? Here we want to take the expansion and write it as a single quantity. This 3 becomes the power, 2 becomes the power, 4 becomes the power. The plus sign we're going to multiply, and the minus sign we're going to divide. So if you got that, we can just write the answer. This is the natural log of x to the third times y squared. This is over z, supposed to be a z. Z raised to the fourth. Let's run that 1/3 through. So this is 2/3 times the natural log of x plus 3 plus 1/3 times the natural log of x minus 1/3 times the natural log of x squared minus 1. Now, let's write this as one quantity. Do you see it? The plus here, we're going to multiply the terms, and then minus, we're going to divide by this term. And then the 2/3, the 1/3 becomes powers, and then after that we can write it smooth. So here, yes, this is the natural log of, first is x plus 3 to the 2/3. This is times x to the 1/3. That's all over x squared minus 1 to the 1/3. Now these fractional powers denote a root, the cube root. This is the natural log of the cube root of x times x plus 3 to be squared. That's divided by x squared minus 1. And that's all in the domain of the cube root. Well, and make sure that this cube root is going all the way down, right? Let's take the derivative. We're using basically here, if y is equal to the natural log of u, this implies that y prime is equal to 1 over u times u prime. Okay, and the book writes it like u prime all over u. So here, f prime of x is equal to 1 over 3x times the derivative now of that 3x, which is just 3. So this is 3 all over 3x, and that just gives us 1 over x. Now, if you expanded that out, this is just another way of doing it. This becomes the natural log of 3 plus the natural log of x. Now, taking that f prime, the derivative of a constant is 0, and the derivative of natural log of x is just 1 over x. So either way you do it, whether you use the algebra to expand, then take the derivative, or just use your calculus directly, you get the same answer. So this one here, we must use the chain rule or the power rule. So this becomes y prime is equal to 4 times the natural log of x to the third power, now times the derivative of the inside times the derivative of 1 over x, or the derivative of the natural log of x, which is just 1 over x. So we simplify that. Y prime is equal to 4 times the natural log of x to the third, and that's all over x. Y prime. Now this is not the whole term squared, it's just natural log of something to be squared. So this becomes 1 over that something, t plus 1 to be squared. Now times the derivative of t plus 1 to be squared, which here, just put that in, times the derivative of t plus 1 to be squared. On that, you must use the chain rule. So the y prime, the derivative of this part is 2 times t plus 1, then times the derivative of t plus 1, which is just 1. So this is 2 times t plus 1 all over t plus 1 to be squared. Simplify that, all we have is 2 over t plus 1. Now, if you don't like that, if you use the expansion from algebra, you can write this as y is equal to 2 times the natural log of t plus 1. Now take its derivative. This implies that y prime is 2 times 1 over t plus 1 times the derivative of t plus 1, which is just 1. So all you have there is 2 over t plus 1. So either way you do it, you get the right result. And as an old R&B song from the 60s, I guess it was the 60s or 70s, that says, ain't nothing to it but the way you do it. Okay, anyway. So here you can do this one of two ways. You can use the algebra and expand, or you can take the derivative as it is. Taking the derivative as it is would involve the quotient rule. Who wants to do that, right? So let's just expand this. So f of x is equal to the natural log of x minus the natural log of x squared plus 1. The only thing about this method is that once you get your answer, you have to then use your algebra to write the fractions as one expression, which is no problem. So f prime is the derivative of the natural log of x, just 1 over x, minus 1 over the term times the derivative of the term, right? So 1 over x squared plus 1 times the derivative of x squared plus 1, which is just 2x. So here, f prime is, I need to put f prime of x there. Sorry for my shorthand notation. Minus 2x over x squared plus 1. Now we combine these two fractions. So f prime of x, our least common denominator, is x times x squared plus 1. So we multiply to this 1 by x squared plus 1. And this is minus 2x, and that's this 2x times this x. So f prime of x is x squared minus 2x squared, then plus 1. Just put the 1 there. This is minus x squared all over x times x squared plus 1. Now, this problem is a problem in memory of my calculus professor, Dr. Wallace Maryland from Alabama State University, of whom on all of our exams he gave problems like this. He never gave like the number 1s and 2s from the homework section. It was typically numbers 107 or number 113. But you gotta love him. So here, oh, how do we do on this test? Well, we all flunked. No, just joking. Well, we won some and we lost some. Well, I had to do okay. I'm here now helping you. So we thank God for our journey. So the y prime here becomes the derivative of the natural log is 1 over the term times the derivative of the term. So this is going to be 1 over the term here is the natural log of x squared. Then times the derivative of the natural log, let's write that, times the derivative of the natural log of x squared. So y prime is now the derivative of the natural log of x squared is 1 over x squared, then times the derivative of x squared. Right, so this is 1 over, write this first part, the natural log of x squared times the derivative of the natural log of x squared, right? So that derivative is 1 over x squared, now times the derivative of x squared, which is 2x. And we simplify, we have y prime, 2x divided by x squared is just 2 over x. So here we have 2 over x times the natural log of x squared, which you see that this 2 becomes a multiplier, and so then it cancels out with that 2 there. So this is 2 over 2x times the natural log of x. And so all you have is 1 over x times the natural log of x. Okay. Now you could work this problem by first expanding using that 2 as a multiplier. So it'll be the natural log of 2 times the natural log of x. So you expand this out. This is the natural log of 2 plus the natural log of the natural log of x. And then if you were using that, the y prime, the derivative of a constant is 0. So this is the derivative of the natural log of x, which is 1 over the natural log of x. Now times the derivative of the natural log of x, which is just 1 over x. And that's the answer, 1 over x times the natural log of x. So either way you do it, you get the same thing. I think we'd better, one of my computer science instructors, we called him, his name was Doug something, and he was, I think we had better expand. That's how he talked. So always funny to hear him. But anyway, it's just funny for me to hear anybody because I get a kick out of everything, you know? You know what I'm saying? So anyway, let's do not hesitate. I need a rhyme for differentiate. Let's do not hesitate. Let's differentiate. That's pretty good. I usually say do not hesitate. Let's integrate. But differentiate also, yes. So anyway, let's expand this. So we're going to expand this. Do you see that this is, yes, 1/2 times the natural log of 4 plus x squared. Then it's minus the natural log of x. The 1/2 is only for the power of the numerator. So now we take the derivative. So f prime of x. You have that 1/2 sitting there times 1 over the 4 plus x squared. Oh, that's visible. Then times the derivative of 4 plus x squared, which is 2x, minus the derivative of the natural log of x is just 1 over x times the derivative of x, which is just 1. So now we do a little cleaning. So the 2's cancel out. We have here x over 4 plus x squared. This is minus 1 over x. So we do a little algebra, do a little Holy Ghost dance. Anyway, so our least common denominator is x times 4 plus x squared. Multiply to this numerator by this x, so it's x times x is x squared, minus the 1 times this term here, in parentheses, 4 plus x squared. It's a parentheses, not an absolute value. It looks like a 4 right there. It's pretty good, man. We can do some elliptic, cryptic writing. Ancient Babylonian, Chaldean, Hebraic writing. Elif, no. So x squared minus the x squared goes out. All we have left in the numerator is a minus 4 over, yes, x times parentheses 4 plus x squared. Just one more. Y prime. The instructions for the natural log of the absolute value for its derivative, the term has to be positive anyway in order to be able to compute the natural log of it, because the natural log, the domain, exists on positive values. So we compute this derivative like we did prior. So this is 1 over the term, which is sine x, and times the derivative of sine x, which is cosine x. And so all we have here is cotan x. Cotan, hello man. Thank you.